Hello everyone and welcome. My name is Garrett, and on behalf of Wiener US in collaboration with Mesytec, I'd like to present our VME-based data acquisition solution. This solution consists of Mesytec's NVMe DAQ software, which includes hardware and readout control, data collection, as well as analysis and visual data display. NVMe is an open source software, which means it's free to everybody, and I'll provide those links at the end of the video for you guys to find on your own. It also has an open architecture allowing integration of other manufacturers' VME readout modules, and has an open software interface to export data from the analysis to professional packages such as root. So why VME? We chose to go with VME because it is the most commonly used open bus standard in nuclear and high energy physics, along with a list of commercially available readout modules for your DAQ system. Moving on to the VME master controller. VME data collection happens nearly in real time with very low latency by using interrupt-triggered list sequencers in the VME master controller. For the best performance, we suggest the Mesytec NVLC controller with USB 3 and Gigabit Ethernet connection, which has an overall data rate between 60 and 125 megabytes per second. Further, the NVLC is outfitted with a flexible triggering logic unit with 14 IOs, which can be configured as trigger in and outputs or gate generators, all with 1 nanosecond resolution. We also offer the VM USB as a low-cost variant option. So what readout modules are available from Mesytec for this system? The new MDPP16 and MDPP32 digital pulse processors, which combine easy-to-use interfaces and high-resolution rate performance. The MDPP digitizers were developed to directly accept any preamplifier or detector signal for wide ranges of detectors. The digital pulse processing is performed with an FPGA with selectable firmwares to allow best pulse processing for the individual detector type. Each firmware is emulating classic analog principles, thus no knowledge of digital signal processing is required. Up to 16K amplitude and 70 picosecond time resolution are achieved while having very low dead time, thus allowing for high data throughput rates. The QDC firmware with 2 integration gates allows pulse shape discrimination. As for analog, we also offer the older analog VME digitizers such as the MADC32, MTDC32, and MQDC32, which are fully supported by the NVMe software. For larger segmented detectors, we offer the MMR system. This works well with detectors such as multi-wire proportional chambers, silicon strip detectors, multi-anode PMTs, etc., from anywhere from 32 to upwards of tens of thousands of channels. Digitization and timestamping is performed in miniaturized detector front-end modules with 32 to 128 channels. The timestamp trigger and data are transmitted via 200 megabyte optical bus to the central data collector module. The VMMR16, which serves 16 optical buses, performs trigger coincidence matching and performs the event building. Many of these VMMR modules can be synchronously read out in one VME crate, thus allowing for thousands of channels. To my right, we have the only portable DAQ system with room for high voltage preamplifiers, VME masters, and the digitizer. Now I would like to show you just how easy Mesytec has made it for you to set up a basic readout configuration and take data. This is shown for a configuration much like our demo setup, including a 16-channel MDPP16 with SCP firmware and the MVLC controller, all of which is housed within a Wiener VME chassis. The MVLC is connected to a Linux computer via USB. Starting the NVMe program asks for the name and location of the workspace folder. When this is created, 3 windows are visible. To the left is the main VME configuration window, in the center is the analysis window, and to the right is the log window. Within the VME configuration window, we first select the correct controller and connection type. Then, an event structure is created which includes the interrupt selection for the VME list sequencer and the module from where to read the event data. In our case, the MDPP16 with SCP firmware is being used. This can be selected from a list of all existing Mesytec modules and other user-definable VME modules. One can change the name of the module to better fit the experiment, and of course, have to set the base address following. For this VME module, 4 configuration text files are created and pre-filled with default settings. For demonstration, we will only change one parameter. We will switch on the internal test pulsar as a data source. Step 2 in the run preparation is to define the analysis settings. For this, we generate the default data filters. For the SCP, this creates arrays of amplitude and time data as well as timestamp and trigger time for our silicone strip A module. In the top field, we have the extracted data. In the bottom field, we have the display data, which can be 1 or 2-dimensional plots. Opening the one-dimensional display of energy, we get a list of histograms, a spectrum for each individual input channel. To start our run, taking data from the internal test pulsar, we define the file name in the run settings and then click on the Start button. In the log window, all VME commands and responses to them will be shown. In addition, we see the run and data rate information in the main VME window. The analysis window will indicate the amount of data processed. In the histogram, we see a sharp line produced by reading the internal test pulsar signals. The DAQ is now running and rates per channel can be seen in the analysis window. The histograms are updated continuously. We can zoom in to the spectra to look and fit the pulsar amplitude peaks for different detector channels. During the run of data acquisition, there is also some visual information being produced from the hardware. First, you will see on the MVLC there is a VME LED on indicating VME bus activities. On the MDBP16, this is shown with the DTAC LED. In addition, all MDBP16 channels have individual status LEDs which indicate with green color a good event. The next step would be now to connect the real detector, disable the internal pulsar, and optimize settings for real operation. At this time, we'd like to say thank you and encourage you to visit our vendor booth. If you have any questions about what you've seen today, please visit us at sales@wiener-us.com and send us an email. We'd be glad to answer your questions. Thank you so much. We look forward to speaking with you.